So for this first problem, you'll notice that I can't divide every term by the same thing. And so that leads me to think, okay, maybe I have to do the whole parentheses squared thing. So I'm wondering, can I make this work? And so in order for that to work, I have to divide the middle number by 2. So what's negative 14 divided by 2? It's 7, specifically negative 7. Question then, what is negative 7 squared? 49, positive 49, which is what we need to multiply to. So yes, that works. So yes, that is our correct factorization method there. And so that one, it's done. That's it. Next one. I again look at each term and I look to see, can I divide every term by the same thing? In this case, yes, I can. What can I divide 9, 12, and 36 by? 3. Absolutely. And so I'm going to start by pulling a 3 out of every term there. And so 9 divided by 3 is 3. Now the x squared part of it, notice I did not pull out any x's, therefore it's just going to stay x squared.
Couldn't you pull out a 1x?
Then the next term, I take the 12, divided by 3 is 4, and the x stays an x. And then finally the 36 divided by 3, that gives us 12. All right, now I just want to double check, did I in fact pull out the biggest number? Looking at 3, 4, and 12, can I divide all 3 of those by the same thing? No, nothing except 1. So yes, that is our final answer. That is completely factored. For that first one, we need to look at every term and see what we can divide out. And so as I look at the 8, the 4, and the 4, what can I divide all those by?
4.
4, absolutely. However, I'm not only going to factor out a 4 in this case. Because as I look at each term, I also see that every single term involves an x. How many x's can I pull out of every term?
1.
1, yeah, because this last x is x to the power of 1. There's only one x in that last term. And so then I'm going to pull out 4x. All right, when I do that then, 8 divided by 4 is 2. And then when I do x to the 5th and I divide that by the x, it's like subtracting the exponent. So I do 5 minus 1 there. So that gives me x to the 4th. Repeat for the rest. Now for this next one, the 4 divided by 4 is 1. And then if I take 1 away from the exponent there, it gives me x cubed. Do I need to write the 1x cubed, or can I just write x cubed? Yep. The x cubed, maybe it's a little bit better style, but they do both mean the same thing. Whether you write the 1 in there or not, it means the same thing. All right, and then finally for that last term, I'm doing 4x divided by 4x. What is that? What is anything divided by itself? Well, like 2 divided by 2 is 1. 5 divided by 5 is 1. Anything divided by itself is 1. And we actually have to have the 1 there. If you leave off this 1, you're going to end up with a problem. And I need to show you why, because if there's any common mistake I see still being made, this is probably it. If you don't put that 1 there, and we tried to go and reverse engineer this thing and work backwards, we would be able to get a decent ways. We'd get the 8x to the 5th and we get the minus 4x to the 4th, but that would be it. We have to have that 1 there, because otherwise there's nothing for us to multiply the 4x to in order to get this one up here. I have to be able to multiply it in order to get that as well. And so that's why, yes, remember that 1 there. All right, last one. Can I divide every term by the same thing? What? Actually, some people are saying like, what about 2 or 3 or 6? Well, that works for the 12 and the 36, but can I divide this by that as well? Can I divide that x squared by 3? No. Can I divide it by 2? No. I have to be able to divide the number out front by that same number. And since I can't take it out of every term, the answer is no, because whatever it factors out, it has to be truly every term. Not just 2 of them, but all of them. So then this one's a candidate for this. Does that work with this one? Let's find out. What's 12 divided by 2? 6. Positive 6 in this case. What's 6 squared? 36. That's what we wanted. So yes, it works. And so yes, that is your final answer there. Now, we've been doing this type of factoring here for a couple days now, where we're looking at how to factor a trinomial like this. And you notice all of these are that similar type. But I'll tell you right now, not all of these are factorable. Please take a look through them. Decide which ones are and are not factorable, please. And then we'll take a look at it together here. So, exactly one of these does not work. Which one doesn't work? Number, how many? Hold up fingers. 1, 2, 3, or 4. All right, I'm seeing a lot of different answers out there. The most common one I'm seeing held up is 3. So let's take a look at number 3. So, in order to factor it into this kind of a form, remember I have to divide the middle number by 2. Okay, so what's 2 divided by 2? That's 1. Okay, so that would mean this would have to be like a 1 here. Okay, what's 1 squared? 1. That's what we have. That means that one works. So actually that one's okay. That's making it tricky because oftentimes we look at that one and we don't think it works because the middle number is actually bigger than the last number. That doesn't happen normally. Okay, so then let's check 4 then, because that was the next option. So if I check number 4, again, if I'm going to set it up like this, I divide the middle number by 2. So negative 8 divided by 2 is negative 4. Okay, what's negative 4 squared? 16, not 64. Therefore, that one does not work. Again, because in order for this to work, I do the negative 8 divided by 2, which gives me negative 4. But then I have to be able to square that number to get the last number. 4 squared is 16, not 64. So as we take a look at these 4, again the question is which one's not factorable? The most common answer I saw held up there was 3. So let's check the third one and see if that one's factorable. Alright, so we start by testing it out, set it up, and we're going to see if it works here. So what's negative 14 divided by 2? Negative 7. Okay. What is negative 7 squared? Yeah, since negative 7 squared is a positive 49, not negative, that's a problem. We can never have a negative there in front of the 49 if this is going to be factorable. Therefore, yeah, the third one is our answer. The third one is not factorable out of these 4. All the others, they are factorable. Now that we got this whole factoring thing down, now we got to be able to put this skill to work for us. And so we're now going to be able to use that skill to solve this equation for x. So please write down this equation, then I'm going to lead you through the process so we can see how it's done. Now, before I start telling you how to do this problem, I need to tell you how not to do it. Alright, so don't write down my work that I'm about to show you because I'm showing you what won't work. But the reason why I'm showing you this is because for most people, if I just asked you to solve it and you just started working on it, this is what most people would do. And so I need you to see why it doesn't work to just do what our instincts might tell us to do. And so a lot of people would actually start by moving that 36 to the other side, which would give us x squared plus 12x equals negative 20. Because I subtracted 36 from both sides. And then what I see at this point is now I got to get rid of the x's. And people make one of 2 mistakes here. Either they try to combine these 2 x's, which notice we can't do because one of them is squared and the other one is just an x. So I can't combine them into a single term. Or they'll say, okay, well then I can get rid of the x by dividing both sides by x. Well, if you divided both sides by x, you have to divide everything on both sides by x, which means the x squared would become an x, the 12x would become a 12. This is looking pretty good, except that the negative 20 would become negative 20 over x. This does not look good. It creates a mess. The fact that we have both an x squared and an x in there actually make the process much more complicated. If we only just had an x or only had an x squared, then we could do it. Then we could use all the methods that we know already. And so that's the trick to doing these, is we are going to turn this into a different form where there is only one x. Now is the part where you do start writing down the work we show here. Because the first thing I'm going to do is I'm going to factor the left side of this equation. And if I factor x squared plus 12x plus 36, of course you're pretty fast at those now, right? In fact, you did this one earlier. We end up with x plus 6 squared equals 16. So you'll notice, all I did there was just factor the left-hand side. But by writing it in factored form like that, you notice what it did for us. I now have only x appearing once. I no longer have a couple x's over there, I just have the one x. It also has another added advantage for us. We've already practiced solving problems that look like this earlier this year. You've seen how to solve these already. So, for instance, what's my first step if I'm going to solve this? Square root, absolutely. So I'm going to take the square root of both sides. In terms of showing the work for this, and I need to emphasize the work because we've gotten a little bit sloppy with our work on this, and it's going to start leading us into some trouble if we continue being sloppy. I write the square roots over both sides, but when I do that, what do I need to remember to include? Yep, the plus or minus. The plus or minus goes in at this point. As soon as you write the square root symbol, you write the plus or minus in front of the square root of the number. You don't need it on both sides. We get into some detail-y stuff there, but we don't need to dig into that. But the beautiful part about doing this is that when we take the square root on the left, it cancels out the squared, and all we have left then is the x plus 6. All right, now when I do this though, since I'm going to get x plus 6 equals plus or minus 4, I get two different answers. I'm going to split this into two different equations. So I got x plus 6 equals 4, and x plus 6 equals negative 4. I want to write it out that way, because what I see happen sometimes is I'll see some of you are starting to do this. X plus 6 equals plus or minus 4. This is a good way to start creating confusion for yourself, because we know that we need to get rid of the 6, but we can very easily start mixing up where the plus or minus is, and it can actually cause some problems if we have to do two operations after this point instead of just the one that we do in this case. So when you do the plus or minus, go ahead and split it into the two equations at that point. All right, now I just need to finish solving each equation. So of course that means subtracting 6 from both sides and subtracting 6 from both sides. This hopefully gets nice and fast. So then x equals a negative 2, and x equals a negative 10. So that's our final answer. Yes, we can go ahead and then write it just as one tidy answer. It's a little bit cleaner if we then say x equals negative 2 and negative 10. You can just put a comma between them to show that these are both solutions. Now make sure at this point, when you wrote the square root in on both sides, that make sure that this is where you include the plus or minus in front of the square root. It is critical that we include it at this step, because if we just kind of try to reverse engineer, get to the end and be like, oh yeah, I needed a second answer, and then you just kind of throw it in, you'll be okay sometimes, you might not be okay every time, especially as these things get more complicated. Notice that when we do this, it's always the number that has the sign change. The x part, it never changes. So since it's x plus 9, it stays x plus 9 on both of them. It's only the number that's by itself that is ever affected. It's only the number that's by itself that ever changes its sign when we do that square root. All right, so then we go ahead and we subtract the 9 from both sides to get our final answer. You should find that x equals 1 and negative 19.